Hi everyone, welcome back to graphing exponential functions and transformations. This is part 2, so we're going to talk about exponential decay, so decreasing exponentially. Now these functions are going to look exactly the same, y equals b to the x, but the only thing that changes here is the b value. So instead of being a whole number like last video, where it was like 5, 2, 10, they're going to be fractions like 1/2, 1/4, 2/5, something that's between the value of 0 and 1. So the transformations will look the same, and I'll just rewrite that. You'll notice this looks like last video, a times b to the x minus h, and then plus k. But I'm just going to remind us that this b value, I'll just do it in this color. So b is going to be between 0 and 1, right? So like 1/2, 1/4. And that happens because when we multiply by a fraction over and over again, so when we multiply it by 1/2 times 1/2 times 1/2, you're going to get smaller and smaller and smaller in value, hence the decay. Okay, so over here, what we have is the parent function y equals 1/2 to the x. So I'm going to write that right here. So that's the graph right here. I already have it graphed, and the 2 points that we see here is again 0, 1. But this point, instead of being 1, b, it's -1, 1 over b. I know that's a little hard to see, but again, just in case you can't see that, it's -1, 1 over b. Okay? So the domain and range is the same actually for this function as last video. So this is all real numbers, and then it's also all the positive values for y. And then again, if we reflect it over the x-axis, that'll make the range negative. Okay? So let's talk about how to transform these two reference points or special points, and then we'll use those rules for the problems below. All right, so the first one, we'll start with this point right here, 0, 1. This is going to transform the same as before, h, a plus k. So if we know those values, we know how to transform this first reference point. The other one's going to change up a little, and this is because our b value is now less than 1. Now it's going to be h minus 1, a divided by b plus k. So you'll see this is now -1, and this is now division. That's how those have changed. Just real quick, if you watched the first video, you'll see that when it's exponential growth, the first reference point transforms the same, the second one's a little different. Okay, so growth +1, decay -1. All right, let's get started. The first problem, let's zoom in a little. We've got 1/4 raised to the x minus 1 plus 2. Now the steps are going to be exactly the same for these problems, guys. List your values, find the asymptote, and then transform your reference points. So I've got an a value of 1, I've got a h value of 1, and a k value of 2. So my asymptote has shifted up 2 units at y equals 2. Write that right there so you guys can see that. And then we're going to find our 2 new reference points. So I'll write them in black first. I've got point 0, 1, and I've got the point -1, and then 1 over b. If I have 1 over a fourth, that's 4. Alrighty. So for the first one, h, a plus k. A plus k gives me 3. And then I've got the point h minus 1, and then a divided by b, so I've got 1 divided by 1/4, that's 4. And then we're going to add k. So 4 plus 2 is 6. All right, let's graph these points. So I've got 1, 3, and I've got 0, 6. So again, pay attention to whether this is growth or decay. Decay on the right side of the function is growing exponentially, but as you move to the right is going to decay and approach the asymptote. So over here, I'm going to start really high and in the really big positive numbers. And then as we move to the right, I'm approaching but not touching my asymptote. So this is like the reflection over the y-axis of our exponential growth functions. All right, next one, doing this in green. I've got 0.5, which is just 1/2, times 1/2 to the x minus 1. So my a is 1/2, h is 0, and k is -1. That means my asymptote has moved down 1 unit, so it's at -1. And we can find our 2 points now. I'll do this off to the right. So for my parent function, before any transformations, I have the point 0, 1, and I also have the point -1, 2. I took the base value and I did 1 over that. All right, for this point, it's going to be h, comma, and then a plus k. 1/2 minus 1, it's -0.5. For this value, h minus 1, so -1. And then we've got a divided by b. So when I do 1/2 divided by 1/2, let's write that real quick. If we remember from algebra, this is the same thing as 1/2 times the reciprocal of that number. So when I do 1/2 times 2, that is just 1. So a divided by b is 1, and then plus k. Alrighty, let's plot these points. 0, -1/2, and then I've got -1, 0. All right, so a little bit of a flatter version of our exponential decay. Remember to not cross the asymptote, but to approach it. Okay, next one, we've got a -a value. Let's see what that does for our graph. Okay, let's list these values. I've got a equals -3. My h value is -2, and then my k value is 7. All right, so that means on this graph, my asymptote is at +7. Let's graph that real quick. 1, 2, 3, 4, 5, 6, 7. All right, I'll label that. Okay, and then we need to find our 2 reference points. Write those in black first. I've got 0, 1, and then the other one would be -1, 2, for similar reasons as the problem before. All right, for this first point, h, a plus k, so -2, and then if I do a plus k, that should give me 4. And then for the next point, h minus 1, a divided by b. So let's do that math real quick. -3 divided by 1/2. We'll do that down here. -3 divided by 1/2 is the same thing as -3 times 2/1. So I get -6. All right, so -6 is the a divided by b, and then we need to add k. So -6 plus 7 is 1. All right, -2, 4, and -3, 1. All right, make sure that we're graphing the shape correctly. We know that we are going to be either really low in the negatives or really high in the positives to the right, and then to the left, we're approaching our asymptote. I'm sorry, to the right. Mixed up my words. So approaching the asymptote and then growing down exponentially. So starting really, really, really low and then getting really close to my asymptote. This is a reflection of the shape you see above. And that is because of our -3 a value. All right, one last problem. This time our base is 1/3. Let's list our values. So a is 2, h is 4, and k is 0. So we've got an asymptote on our x-axis. I draw my lines a little weird there because that line is so solid that I want you to be able to see the asymptote. All right, first point, 0, 1, and second point, -1, 3. Okay, so for this one, we've got 4, comma, and then when I do a plus k, that's 2. And then for this point, let's see, h minus 1. And then we do a divided by b. So down here, I'll do that math real quickly. 2 over 1 divided by 1/3 is the same thing as 2 times 3. So I've got a divided by b is 6, and then plus k. So it's just still 6. All right, guys, this point is 4, 2, and 3, 6. So this is a positive exponential decay function, so we're going to start really, really high, and then as we move to the right, we're going to approach this asymptote, but never touch it. So it's going to like right alongside it. All right, thanks so much for watching, guys. Definitely, if you have any questions on these graphs, make sure to watch part 1. That's going to answer a lot of questions just about the basics of graphing. All right, thanks so much. See you guys later.